Recording in progress.
Okay, so good morning to you all. Today we'll be talking about confidence interval, p-value, alpha value, hypothesis testing, and a whole lot. But before we go into that, I think I want to talk about normality testing. It is not in this slide, but I feel it is very important. So this video will be about normality testing. So what is normality testing? Normality testing, it's more like the test we carry out. We use our SPSS to carry out to find out if our sample was drawn from a normal distribution. And the test for normality in SPSS is the Kolmogorov-Smirnov test. And the Kolmogorov-Smirnov test is used to test for normality in sample size of greater than 50. That's 50 and above. Sample size of less than 50, you use the Shapiro-Wilk test. So, okay, so since it's not on this slide, I kind of made notes. So I'll be making reference to my notes and to the SPSS. Okay, so I think I want to stop sharing. Let me just annotate here. Okay, so in Kolmogorov-Smirnov test, there are assumptions we make while we do our normality testing, and the assumptions are that our null hypothesis, the data for that variable is gotten from a normal distribution, and then our alternate hypothesis is that data is gotten from the data is not from a normal distribution. Okay, so this is for the Kolmogorov test, Kolmogorov-Smirnov test. These are the assumptions we make. Kolmogorov-Smirnov is a test. So these are the assumptions we make in Kolmogorov-Smirnov test. Our null hypothesis, data is gotten from a normal distribution, and then our alternate hypothesis, data is not from a normal distribution. Now, if our p-value set at 0.05, p-value is also known as probability value. Our p-value set at 0.05. Since I didn't make a slide on this, I'm just trying to type so that people will follow me. So our p-value set at 0.05. If our p-value, also known as probability, is greater than 0.05, it means that the okay, so a high probability value means that the deviations means going further away. So the deviation away from normal distribution is small. And so there is a high likelihood that our distribution, as our sample, was from a normal distribution. I repeat, a p-value or a probability value greater than 0.05 means that the deviations away from the normal distribution is small. And since this our deviation is small, there is a high probability, there is a high likelihood that our sample was drawn from a normal distribution. So if P is greater than 0.05, then it means that our null hypothesis stands. On my right. And if our null hypothesis stands, it means that our data is, there is a probability that our data is gotten from a normal distribution. Now, if P is less than 0.05, it means that there are large deviations away from a normal distribution. And since there are large deviations, the probability that our sample was drawn from a normal distribution, there is a less likely probability that our sample was drawn from a normal distribution. I repeat, if P is less than 0.05, it means that our deviations away from the normal distribution is large. So there is a less likely chance that our sample was drawn from a normal distribution. So if our P is less than, I'm just trying to establish ground rules. If our P is less than 0.05, it means that we reject the null hypothesis. And if so, we reject the null hypothesis. So we don't say the statistical lingo is that we reject the null hypothesis. We don't say we accept the alternate hypothesis. We are not accepting because it's probability. We are working under the umbrella of chance. So because of probability, so we are still giving that giving room for that chances. So we cannot accept, we cannot confirm. And besides, normality testing does not confirm to you that your sample was drawn from a normal distribution. It just gives you an idea, a probable idea that your distribution was drawn from a normal distribution. Your sample was drawn from a normal distribution. It doesn't confirm that your sample was drawn. It just says that there is a likelihood, there is a chance that this sample was drawn from a normal distribution. So if P is less than 0.05, we reject the null hypothesis. And since we reject the null hypothesis, we now conclude that our data is not from a normal distribution. So this is normality testing for you. I've established ground rules, and I think we'll go to the SPSS. Okay. Let's say we want to find out if any of these variables, okay, let's say relationship status was the samples drawn was from a normal distribution. Like in statistics, we always make this assumption that our samples were drawn from a normal distribution. So this normality testing helps to give us an idea, to let statisticians know have an idea, the chances that, okay, this was drawn from a normal distribution or this was not drawn from a normal distribution. Mind my language, I did not see to confirm. So first, for me, it depends on different people, but for me, I like to go to my graphs first, my legacy dialogues. Okay, so graphs, legacy dialogues, histogram. Okay, so relationship, display normal curve, and that is my output not showing. Okay. All right. So from this graph now, from what we talked about skewed and non-skewed data last, you can see that this is a right skewed data. You can see that the tail of the graph of the curve is moving towards the right. So you can see that this is a right skewed data. So it's giving you an idea that, okay, this is not from a normal distribution. You're just screening for the normality. But then if you kind of want to go further, you go for your normality testing, you go to analyze, you go to a non-parametric test, you go to legacy dialogues, go to one sample Komogorov, that's one sample KS. So sorry. So we put in our relationship and we don't need any of this. We just press continue. I'll press OK. All right. So this is our Komogorov's main of test. And here it's showing that, remember in SPSS, our p-value is always notified as asymptotic sig to the as our p-value is always written as sig. And here we can say that this is less than 0. This is 0.00001. So it's still infinity. And so definitely this is less than 0.005. And so since this is less than 0.005, we can say that the deviation from a normal distribution is high. And since the deviation is high, our probability will be low. That means there is a less likely chance that this sample was drawn from a normal distribution. Now, if you look below, you see test distribution is normal and be calculated from data. The A is here, that's the assumption that our distribution is from a normal distribution, and then the B that is signified here is telling you what the SPSS calculated from the data in the software. So our Komogorov's Smirnov value is 11.987, and then our asymptotic is less than 0.005. So our alternate hypothesis stands for this, and we can say that our data was not drawn from a normal distribution for this relationship status. You can also, another way of running a non-parametric Kolmogorov test, you go to analyze. Okay, what are these things blocking my screen? Okay, go to analyze, you go to descriptive statistics, you go to explore, and you put in your relationship status that you want to find out. Click on statistics, everything is If you want to change your confidence interval, you can change your confidence interval to 99, but no, we want our confidence interval to be 95. Press continue, go to plots. You uncheck, make sure okay. I don't think I unchecked all these things, but you go to plots, you uncheck your stem and div and click on histogram. Let me do this so that plots. So you click on histogram. If your stem and div is already checked, you uncheck it. You click on your histogram, you click on your normality plots to test, click on and continue, click on OK. You can see if you follow this route, it's showing you the Kolmogorov-Smirnov and then the Shapiro-Wilk. Can you see? So, like I said, Shapiro-Wilk is usually for samples less than 50. There are samples of 50 or less, and then it can also be used for samples of more than 50. But Kolmogorov uses majorly for samples greater than 50. So you can see here that our significant value is 0.0000, which is less than 0.005. And you can say that the data was not drawn from a normal distribution. Okay, so that is that for normality testing. It's as simple as that. Just to recap, normality testing does not confirm, it just gives you an idea the chances that your data was drawn from a normal distribution or not. If P is greater than 0.05, it means that our probability is high. That is, the probability that our sample was from a normal distribution is high. That means our data was drawn from a normal distribution. So if our P value is less than 0.05, it means that the probability that our sample was drawn from a normally distributed data is low. So there are large deviations away from normal distribution. And so we reject the null hypothesis and say that our data is not normally distributed. So that is that for Kolmogorov-Smirnov. Did I write down anything to? All right, no. Okay, thank you so much. And that is all for normality testing.